Hi, and welcome to the third experiment with my Pico sensor board. I have taken what I did in the first, or rather the second experiment, in which I had a turn coordinator for my plane, in which I would turn the bottle and the plane would tilt depending on the direction of the water bottle. And also, if it lost its connection or had all the connections going, it meant the plane was in a spin, so the actual indicator would spin around. I've modified it slightly, and I've created this. It's called an attitude indicator, which is used on planes to indicate the pitch of a plane and also the banking angle. What the user can now do is use the, like we did with before, tilt the bottle to get it to change the pitch, but also use the slider option on here to change the pitch of the plane. I've got alarm systems in place. If you pitch up too high, or if you pitch up or pitch down too low, the alarm will go off. Again, if you bank too heavily, then the alarms will go off. And if you go into a spin, the alarms go off. So I'll show you it running, and then I'll walk you through how it works. So I'll just click run. Okay, so first of all, I can control the pitch with my slider board, so you can see it on the diagram there. I'm controlling the pitch. If I pitch up too high or too low, then the alarm goes off. Okay, back to normal. I've got it set to an otter noise at the moment, but whatever. And pitch down too low, the alarm goes off. There we go. I'll turn it back to the middle. Okay. So that's the first part. That's the pitch. The other part again is if I turn it one way and turn it the other way, I'm going to call it the banking bug moves. If I go too far, alarms go off. If I go the other way, and if I spin it, everything kind of goes a bit haywire, and then returns to normal when everything's in level flight. While it's spinning, I'll turn it down. While it's also spinning, I can change the pitch still, so I thought it would be fun for the kids to kind of still be able to experiment with the pitch while that's going, set up two alarms at the same time. And yeah, so let's have a look how it works. I'll stop it. And for this actual project, I've got three elements. I've got a housing section, which has no scripts. I've got a bank section, which is the inner circle, and then I've got the attitude, which is essentially just a bar with some colours on. So let's take a look at the banking one first. It's very similar to the one I had before. I've got checks here to see if A, B and C are connected at the same time. If they are, set an alarm and get it to spin round 15 degrees per cycle. But I've also got it to set a variable called spin to true. And that will be activated in the attitude section. Sorry, the attitude section of the script over here, and I'll show you that in a minute. If it's not spinning, then I set the spin to false, and then I just check to see what's going on with the sensors, to see what's connected. So the first one checks to see if sensor A is connected. If sensor B or C are not connected, but A is, then we're in level flight, so point the direction of this bank to 90. If sensor B is connected, whilst A is connected, then point the direction of 60 degrees. If it's not B, then it must be C, so point it the other way. If sensor B is connected and sensor A is not connected, then we set the alarm going off and we have a steeper bank, and the same thing happens with C down here. The final check is to see if sensor A is not connected, and if it's not connected, I want to check to see if B or sensor C are not connected either. If they are not connected, then we set it to go into a spin as well. So let's have a look at what happens when we're in a spin. I set the attitude. I do a check, first of all, see if the spin is true. If it is true, then I set the actual attitude sprite to spin around in the opposite direction this time. And I also set the pitch to whatever the slider value is, -87. The reason it's -87 is because the slider has a value of 0 to 100. So the way the y-axis works is if I set it to 0 to 100, it's just going to go really high up or really low down. I can't remember which one it is now. So I originally had it set to -50 because then I could have a range of -50 to +50. But then I've moved the actual the actual, it's not in the centre, it's slightly below centre by 37, I think. So it's minus 50 minus another 37, which gives you minus 87 to give you the slider value. And then I set the y value equal to the pitch. Then if it is all back to normal and the spin is actually equal to false, then what I do is I set the direction equal to 90. Well, I keep turning it until it is equal to 90. That gives you kind of a smooth kind of rotation rather than just snapping back. It smoothly rotates back into normal place. And then I do the same thing again. I set the pitch equal to the slider value, minus 87. Set the y value. And this is where I have my little check to see if it's too extreme either way, either too pitched up too high or pitched down too low. That will set off the alarm. And that's it. It's just a little extension, and I think very suitable for those who are looking for a slightly harder challenge out of this kind of activity. Maybe suitable for like the gifted and talented. I'm still trying to figure out how to extend it further. If you've got any ideas, leave a comment. But I would like to try and build it up even further to include more sensors from the sensor board to really push those kind of gifted and talented students. The weaker students who are going to be doing this, more than likely going to be just kind of getting it to activate a sensor, maybe going on to doing just the pitch and the slide bar, because that's fairly straightforward. The sensor one is a little bit more involved, as you can see from the actual amount of code that you've got to write and the amount of error checking that you've got to do. The actual slide bar is pretty standard and good for those students who are kind of struggling with this kind of activity. But I really want to find something that's going to really kind of initially push those more able kids who are they're all learning how to program, but I really want them to kind of get involved with it. So if, like I said, if you've got any ideas, put a comment down and I'll it'd be great to hear from you guys. So all right then.